To provide a common reference, the International Standard Atmosphere, ISA, has been established. These standard conditions are the basis for certain flight instruments and most aircraft performance data. Standard sea level pressure is defined as 29.92 inches of mercury, and a standard temperature of 59 degrees Fahrenheit, 15 degrees Celsius. Atmospheric pressure is also reported in millibars, with 1 inch of mercury equal to approximately 34 millibars. Standard sea level pressure is 1013.2 millibars. Typical millibar pressure readings range from 950 to 1040 millibars. Since weather stations are located around the globe, all local barometric pressure readings are converted to a sea level pressure to provide a standard for records and reports. To achieve this, each station converts its barometric pressure by adding approximately 1 inch of mercury for every 1,000 feet of elevation. For example, as shown above, a station at 5,000 feet above sea level with a reading of 24.92 inches of mercury reports a sea level pressure reading of 29.92 inches of mercury. Using common sea level pressure readings helps ensure aircraft altimeters are set correctly, based on the current pressure readings. As pressure decreases, the air becomes less dense or thinner. This is the equivalent of being at a higher altitude and is referred to as density altitude, dA. As pressure decreases, dA increases and has a pronounced effect on aircraft performance. Altitude affects every aspect of flight, from aircraft performance to human performance. At higher altitudes, with a decreased atmospheric pressure, takeoff and landing distances are increased, as are climb rates. When an aircraft takes off, lift must be developed by the flow of air around the wings. If the air is thin, more speed is required to obtain enough lift for takeoff. Therefore, the ground run is longer. An aircraft that requires 745 feet of ground run at sea level requires more than double that at a pressure altitude of 8,000 feet, as shown in the figure above. At sea level, atmospheric pressure is great enough to support normal growth activity and life. By 18,000 feet, the partial pressure of oxygen is reduced and adversely affects the normal activities and functions of the human body. The reactions of the average person become impaired at an altitude of about 10,000 feet. But for some people, impairment can occur at an altitude as low as 5,000 feet. The physiological reactions to hypoxia or oxygen deprivation are insidious and affect people in different ways. These symptoms range from mild disorientation to total incapacitation, depending on body tolerance and altitude. Supplemental oxygen or cabin pressurization systems help pilots fly at higher altitudes and overcome the effects of oxygen deprivation.